Today we're going to talk about parts of an equation. You will follow along with your chemical reactions notes that you started on April 6th and fill in the blanks from there. A chemical reaction is a chemical change resulting in a new substance with a new chemical formula. Let's talk about a chemical formula. Way back in October, we studied the periodic table, and on the periodic table, all elements had their own chemical symbol, such as sodium symbol is Na. That'd be a capital N and a little a. And then chlorine symbol is Cl, capital C, little l. And when the two of them, sodium and chlorine, come together, they form salt, which is sodium chloride, and that chemical formula would be NaCl. Another chemical formula would be H2O that we know from water. H is for hydrogen and O is for oxygen, but H2O tells us that there are two hydrogens and only one oxygen, but that's in the molecule that it forms. And so the chemical formula represents the molecule of that particular compound. In a chemical reaction, one or more substances are changed into a new substance with new physical and chemical properties. And so that's where we're going to pick up from here. Now, there's an image here on chemical equations, and it actually shows the chemical equation three different ways. The first one on the top is pictorially, and we see that the black circle represents carbon, the white circles represent hydrogen, and this is the methane molecule where there's one carbon and four hydrogen. Over here next, we have the red circles represent oxygen, and oxygen bonds with itself. There's 7 elements that bond with themselves to be more stable. And so oxygen actually exists as O2, or a combination of the two oxygen atoms combined together. And so you may have, when somebody goes to the hospital and they need to go on oxygen, they go on O2 instead of just O, because the O molecule by itself is very unstable. Anyway, so then we have the arrow, which is where the reaction takes place. And the ones on the left side of the reaction are what we started with. The ones on the right side of the arrow are the products of the new substances that we have produced. And in this case, in this reaction, we have the black circle, which is carbon, bonded with 2 oxygens. Notice that that is different from what we started with. And that is the carbon dioxide molecule. And then we have 2 water molecules. Once again, 1 oxygen, 2 hydrogen. And you'll notice that the water molecules, the 2 hydrogens are on the one side of the oxygen, and that creates what's known as a polar molecule. It's a property of water. So the shape of the way this drawing is actually comes into play. We're not going to get into that here in 7th grade chemistry. This is just meant to show you that we can represent this chemical equation with a picture. Next, we have words where it says 1 methane molecule plus 2 oxygen molecules produces, the arrow is sometimes called referred to as produces, 1 carbon dioxide molecule plus 2 water molecules. And then the way that we're going to do this is through chemical formulas inside the chemical equation. So CH4, that represents the methane molecule, plus 2O2, which represents the oxygen molecules. And notice that the coefficient of 2, the big 2 that comes out front, so that there's 2 of them. So I have O2 here and I have O2 here, but I have 2 pair of those oxygen molecules, and that's what those different numbers represent. And then it produces CO2 plus 2 H2O. Again, I have 2 pair of the water molecules. So the chemical equation represents the chemical combining of elements and or compounds, which means we have the reactants and we have the products. Next, I have a video here that I recorded for you, and it is using lead nitrate and potassium iodide. We're going to watch it. Mr. Wise, we're going to talk today about chemical reactions. And what I'm going to do for you today is to demonstrate a chemical reaction. And this is a chemical reaction that you'll find in your notes. I have you labeling this equation in your notes. I don't have the full equation written down here, but we'll focus on this area down here. I have 2 reactants. A reactant is something that goes into or starts in a chemical reaction. It's what you start with. And so I have lead nitrate, which is PbNO3, and then I have potassium iodide, which is Ki. You'll see that they're both white solids. Now, in this Erlenmeyer flask, I have some of that lead nitrate dissolved in water, and in this Erlenmeyer flask, I have some of this potassium iodide dissolved in water. And what I'm going to do is I'm going to combine them. They are going to go into the chemical reaction, which reactants go into the chemical reaction and products come out. There are 4 signs of a chemical reaction. These are signs of a chemical change: color change, temperature change, producing a gas, sometimes in the form of bubbles, and producing a solid. And if you produce a solid out of 2 solutions, it would be called a precipitate. A precipitate is when a solid crystallizes out of solution. In other words, it forms crystals, it forms a solid as a result of the chemical reaction. So here we go with the lead nitrate, the PbNO3(2). I'm going to pour that into the potassium iodide, Ki. Now, as I pour that in there, you immediately see that it changed to a brilliant yellow color. One of the ingredients in this is Pb, which is lead. Lead used to be used in paints. Now, lead, if you look at it on the periodic table, it's number 82 on the periodic table. And so it has a lot of protons and a lot of electrons, a lot of neutrons in it. So it's a very heavy metal. And lead paints tended to chip. Well, lead caused lead poisoning. And so since 1978, we have not used lead paints in homes anymore. There's a disclosure for that. But one of the things is that the reason that they were used in paints is because lead compounds form these brilliant yellow compounds. So as we look at this Erlenmeyer flask, and I'm going to come back with another video in just a few minutes after this has time to settle, this is actually produced not a yellow liquid, but it produced a yellow solid. That is the new solid that was produced, the product which was produced, which is the lead iodide, the PbI2. And then we'll have a clear liquid in there, which was the potassium nitrate, KNO3. And we'll show you a picture of that in just a little bit. So on the next slide, I lied a little bit on the video. I didn't actually record another video, so I guess this video will have to suffice for that. This is just a few minutes after letting it settle. If I had more time, I would have let it settle a little bit more, and the clear liquid would be a little bit more clear. Some of the lead is still suspended up into the liquid, but it is a clear liquid. And then we have this yellow solid that's down here in the bottom. Now, I did say in the video that lead forms bright yellow compounds. It actually forms bright compounds. From the lab that you did, the physical and chemical change lab on the previous day, there was the one step where we mixed hydrochloric acid with lead nitrate and we formed a white precipitate. Mr. Derriman said in that video that it looked like snow. So this is the yellow precipitate, which is a solid as produced. And so what we had was those 2 white solids that I showed in the video. Those were the reactants. Those are what I started the reaction with. And then I mixed them together. I put them with water, dissolved them in solution, and I mixed them together, and they reacted to form this clear liquid and this yellow solid. So that was a chemical reaction. And that chemical equation is listed out here. And if you're using the notes, especially the copy of the notes that I sent you via email, you should be able to type into that fillable form. I've had different varieties of students come back at me with different feedback. Some were successfully able to do the PDF fillable form, some were not. And unfortunately the tech is what it is. But if you check the email that I sent you on Monday, April 6th, that had the 3 worksheets from last week. One of those was the notes, and hopefully that document you're able to type into. So there is one spot where you're going to label this 2 that's in front of the Ki a coefficient. Now, a coefficient is a number that indicates how many compounds or elements are present in a chemical reaction, and it's written in front. Key part there, it's written in front of the formula or symbol. Coefficients are only used in chemical equations. We would never use a coefficient just for a chemical formula by itself. It's only when it's part of this larger equation. And in math class, you might have 2x plus 1 equals 7, or an equation like that. And the 2 in front of the x, the 2x is also called a coefficient. And so it affects the same way. Remember, the rules of math apply to science just the same way too. Then we have this smaller 2, which is labeled a subscript, just like the little 3 here and the 3 and the 2 that we have there. The subscript is a smaller number written after. That's key there, after. Keep in mind the coefficient comes in front. The subscript is a smaller number that's written after a symbol that tells you how many atoms are present in the compound. And this is just in a compound. So this isn't a chemical formula. And so like H2O, we can have a subscript in a chemical formula, but not be part of a chemical reaction or a chemical equation. The next 2 parts that I want you to label on your notes are reactants and products. You'll see this bracket here on the left. The left side of the equation of the reactants, those are the substances that are about to react. They are what enter into a reaction. And then the products are listed on the right. They are the new substances that are produced. They're what come out of it. So the reactants on the left in that equation were those 2 white powders or the 2 clear liquids once I dissolved them in solution. And then the products were the yellow solid and the clear liquid that was produced. Next, and you'll probably want to go into the slideshow to get a little bit more time on this, but you will see that there's a paragraph and I have the red words for the word bank. So after I'm done talking about all this, you probably want to go into the slideshow and take a little bit more time to fill in those particular blanks. And I have that. Here's what that final equation should look like. The one thing I didn't talk about was the arrow. The arrow is pronounced as yields, reacts, or produces. So sometimes when we're reading it, we might say potassium iodide plus lead nitrate yields potassium nitrate plus lead iodide, or we might say it produces it or reacts to form. It's just different ways that we pronounce the arrow. And then we have another paragraph. Once again, you want to take some time to go through there and fill in the blanks. I've had an email that asked me if I'm going to give you the final answers then. But for right now, I want you to fill in these blanks and go through the notes and spend a little bit of time doing this. It's especially important right now since we're not all together in the classroom for you to be able to do that. So that is the parts of equation notes. We will continue on with the notes on other days on the other sections of the notes as well. Have a good day.